Welcome to the Planet of Maths channel. In this episode, we will talk about similar triangles. First, we will briefly discuss the postulates of triangle similarity, and then we will move on to exercises. There are three postulates for triangle similarity. The first postulate is angle, 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 which states that triangles are similar if three angles of one triangle are equal to three angles in the other triangle. For example, in such a situation, here in the triangle, we have angles of 60, 40, and 80. And we have the same angles in the second triangle. Then we can definitely determine that the triangles are similar. Similar, meaning they have the same shape, only they may differ in size. And here it's also worth noting that if I only knew two angles in a triangle, that's actually enough. I supposedly don't know this third angle. Here I also supposedly don't know this third angle, but if two angles are the same, then if we calculated it, this third angle would be exactly 80 degrees. It must be that much. And the same is true for this other triangle. So I know two angles, and the third angle, once calculated, would also give me 80 degrees. So the angle, angle, angle postulate can basically be shortened to just two letters A. If we know that two angles are identical in one and the other triangle, then we already know that the triangles are similar. And this is probably the most important postulate of triangle similarity. It is most commonly used. The second postulate is side, side, side. That means two triangles are similar if the ratios of corresponding sides are equal. The point here is that if we divide the corresponding sides of one triangle and the other triangle, we will always get the same result. If I take the shortest side from this smaller triangle and the shortest side from this larger triangle and divide them, 4 divided by 10, reducing it, I get 2/5. That's the first pair of sides. Now I'll check the bottom sides, starting with the smaller triangle again. So it will be like 8 on top, and the corresponding side to this 8 is 20. So I put 20 on the bottom. This fraction simplifies by 4. 8 divided by 4 is 2, and 20 divided by 4 is 5. And again, I got 2/5. Just like here, so far, so good. And now, the third pair of sides must also give me the same result. So I check 6/15. I divide the 6 from the small triangle by the 15 from the big triangle. I can simplify this here by 3. 6 divided by 3 is 2, and 15 divided by 3 is 5. And again, I got 2/5 here. In each case, the result was 2/5, which means that the sides of this triangle and the sides of that triangle are proportional. Corresponding sides are proportional. It means that these triangles are similar. And there is also a third postulate of triangle similarity. It is side angle side. It states that two triangles are similar if two sides of one triangle have the same ratio as two sides of the another triangle, and the included angles are equal. Starting from the end, in these triangles, we have equal angles. Here is 60 and here is 60, and the sides should be proportional. If I take 4 from this smaller triangle and divide it by 7 from the other triangle, I get some fraction, and I should get the same by dividing 8 by 14. When I divide 8 by 14 and then simplify by 2, I get 4/7. And that means that these sides of this small triangle are proportional to those sides of this larger triangle, because I got the same result from one division and the other division. That's it regarding the postulates of similarity. Let's move on to the examples. In the first example, we know that the triangles shown in the diagram are similar, so we don't need to check this anymore. We already know it. We need to calculate the missing sides of this triangle. First, we need to match the sides. This 4 corresponds to 6. These are corresponding sides. The corresponding sides are also x with 10. Out of this, I can set up a proportion. If I take x from the small triangle and divide this x by the corresponding side to x from the large triangle, which is 10, I will get the same as this 4 on top from the small triangle. So it's like putting the sides of the small triangle on top, and the sides of the large triangle that match the sides of the small triangle on the bottom. X matches 10, I put x over 10. 6 matches 4, so I put 4 over 6. Here I have an equation in the form of a proportion. I can cross multiply it, so it will be x times 6 is 6x. On the other side, I multiply 10 by 4, which is 40. I divide all that by 6, so 6 goes down here, 6 goes down here. That leaves me with x, and here I have 40/6, which I can simplify by 2, and that gives me 20/3. This is the length of segment X, this segment. I still need to calculate segment Y. I will calculate segment Y again by setting up the appropriate proportion. If I want to calculate Y, I can start from the smaller triangle. I can start from the larger triangle. It's important to stick order. I start again with the smaller triangle. 8 fits with Y, so I'll do 8 over Y. I started here with the small triangle, move to the large one. Similarly, I will go here from the small triangle. I'll start with the 4. I'll go to the large triangle with the 6, so it will be 4 over 6. And again, I have proportion. I can cross multiply here again. First, I'll cross multiply this diagonal with Y. That will be 4 times Y, which is 4Y. And in the other direction, I multiply 8 times 6, and that is 48. I divide everything here by 4 and immediately get that Y equals 12. So I've calculated Y. Earlier I've calculated X. The task is done. In example B, we have this situation. These triangles are rotated somehow. But still, we can identify which side matches with which one because this side is definitely the shortest in the small triangle, and with this 3, a 6 will match because 6 is the smallest side in the second one triangle. I know that the 6 corresponds to the 3. And then for that Y is the longest here. To Y, 10 will definitely fit because that's the longest side of this large triangle. And in that case, the side X will definitely correspond to the 4. These are the side's appropriate ones. And if I want to calculate Y, then I'll start with Y from the small triangle. To Y fits the 10 from the large triangle, so I divide Y by 10, and from this I get. From the small triangle, I take 3 because I know it. And I divide it by 6, which I also know in this large triangle. Those were the matching sides for each other. I can now cross multiply this. I start with the cross including Y, so Y times 6, that is 6Y. This equals 10 multiplied by 3. That comes to 30. I divide everything by 6, and now it turns out that Y will be equal to 5. And that's my first result. Now I still need to calculate X. For X, the number 4 fits from this smaller triangle. Side 4, that is the medium side of this triangle, I start from the small triangle, I take the 4th. I divide this 4 by X, and I'll take the sides I know and that match, which are 3 and 6. I started from the small triangle, so 3 on top and 6 on the bottom. And now I can cross multiply starting with X. Here it is, X times 3, I get 3X. This equals the other side. I multiply 4 times 6. That is 24. I divide all by 3 and get that X equals 8. End of example B. In the second task, I first have to check if these triangles are similar, and only then can I calculate the missing sides. So far, we don't have a full guarantee that these triangles are similar, but we have angles here. This angle alpha, let this be such a blue angle, we have a second identical angle in this triangle. Here, the blue angle alpha also exists in this triangle. I have a green angle beta in this smaller triangle, and I have a green angle beta in the second triangle. And from this angle-angle postulate, I already know that these triangles are similar. Then for sure, this third angle, kind of orangish, is the same as this angle here. I don't know how much it is, but for sure this angle and this angle are the same. And now, when setting up proportions, these angles will help us. Opposite this blue angle alpha, I will have a blue side X here. Opposite alpha is this side. And matching this blue side X, there will be a side located here, opposite this blue angle alpha. So that is side 14. The corresponding side to side X is side 14. Further, the green angle beta, opposite the angle beta, is 8. And this green side 8 will correspond to the side in this triangle that is opposite the angle beta. The angle beta is here. Opposite this angle beta, we have this side. This green side 16 matches the side 8 because both are opposite the angle beta. Opposite this orange angle is side 6. So for this side 6 and this triangle opposite the orange angle is side Y. To this 6 matches side Y. And now we can set up proportions. I would start here by taking those sides that I know and that match each other. I won't take this X for now. I won't take Y for now, because I don't know these sides. But, for example, I know that this green side 16 matches the green side 8. So I will start with these two sides. I will take the 8 from the smaller triangle and divide it by the 16 from the large 1 triangle. If I want to calculate x, I will take x on the top, that's the blue x, and divide, what do I have blue here? In this triangle, I have a blue 14. This is my proportion. Here I can simplify it. 8 and 16 nicely simplify by 8. Here I will have 1 and 2 after simplifying. Now it will be easier to calculate because diagonally when I multiply, I will multiply x times 2. I will get 2x, and that equals 1 multiplied by 14, which is 14. I divide by 2, and I get that x equals 7. I already know x. Now I would also like to know y. Again, I'll start with those known sides. I'll start with 8 and with 16. I'll divide 8 by 16. I started from the small triangle, and I divide it by 16 from the large 1 triangle. And now, in this ratio, I want to have y. I will definitely put this y here at the bottom, because at the bottom, I put the sides from the larger triangle. Y is orange, so to this y from the smaller triangle, the orange side 6 will match. This side matches y, so I put 6 here at the top. I have a green 8 over a green 16. That equals orange 6 over orange y. The proportion is set up correctly. Now I can calculate. First, I will simplify again to make it easier. Here will be 1, here will be 2. Now in my proportion, I will multiply this y diagonally with 1. Y times 1 is y, and that equals 2 times 6, which is 12. And I have calculated y. In example B, I have these two triangles here. They are also placed oddly in relation to each other. We first need to make sure that these triangles are similar. And again, the AAA postulate will work for us here. Actually, 2 angles will suffice. Here we have a right angle in this blue triangle, and we have such a right angle in the green triangle. So we already have 1 angle. We still need a second angle, and this second angle will be the blue angle in this place, because this angle and this angle are congruent, as these are vertical angles. So I already have 2 pairs of angles. I have a right angle and a blue angle in the small triangle. I have a right angle and a blue angle in the large triangle. This means that this orange angle in the small triangle will also be the same as this orange angle in the large triangle. So we have a blue side 4 opposite the blue angle. We have a blue side 5 opposite the blue angle. We also have an orange side 12 opposite the orange angle. I have the orange side x, which is opposite the orange angle. And I also have the green segment y, which is opposite the right angle, and the green side 13 fits it, which is located opposite the right angle. I've marked it all colorfully, so I can then arrange proportions. I want to calculate x, so I'll go like this. I'll first take this blue side 4 from this smaller triangle and divide it by the blue side from this larger triangle. The blue side is 5, so I divide 4 by 5. And here I went small triangle, large triangle, in blue I went. If I want to calculate x, this orange x, then at the bottom I put the orange side from this triangle, and the orange side is 12. This is the side corresponding to side x. Nothing cancels out here, so I need to cross multiply. I first multiply here with the x. X times 5 gives me 5x, and from the other cross, I get 4 times 12, which is 48. I divide everything by 5 and get that it will be x equals 48 fifths. Because this 5 appeared here at the bottom, and it canceled out here. And here 5, when it appears at the bottom, it results in such a fraction. X is calculated. Now for y. I will calculate y this way. I'll take the 4 and the 5 again, these blue sides. I start with the 4 from the small triangle, divided by the 5 from the large triangle. These are the blue sides. And now I want to calculate the green side y from the small triangle. So I put y on top, because I have the sides from the smaller triangle on top. And y was green, and for this, y, 13 fits. 13 is also green from the large triangle, so here I put 13 at the bottom. From this proportion, I will be able to calculate y. It goes like this. 5 times y is 5y. That equals 4 times 13. 4 times 13, that is 52. I'll divide it all by 5. Here 5 at the bottom, and here 5 at the bottom. Here the 5's cancel out, leaving y, and nothing happens here. We write that it is 52 fifths. If someone really wanted, you could convert this to a mixed number, but it's not necessary. That would be 10 and 2 fifths. In example C, we must calculate this segment X. This is segment LB. We know that segments AB and KL are parallel to each other, meaning this is parallel to this. So first, we make sure that these triangles are indeed similar triangles. Triangles are here. There is a small triangle KLC and a large triangle ABC. These triangles will be similar because if we look at this smaller blue triangle, in this triangle, we have a purple angle here. And because this line and this line are parallel, this angle will be the same as this angle here at the bottom. These angles are corresponding angles, and they are certainly the same. On the same principle, this red angle from the smaller blue triangle will also be in this position. These are again corresponding angles. And if we now look at these triangles, I would separate them here. I would take this smaller blue triangle and draw it here. This is triangle KLC. In this triangle, I have this purple angle and this red angle. In this triangle, I also know side 7. Side KL has a length of 7, and side CL has a length of 3. That's what I know in this smaller triangle. And now I look at the large green triangle ABC. I draw it here on the side, and in this triangle, I definitely have 21 at the bottom. What else do I know? I also know the angles. I know that here is a purple angle and here is a red angle. I established that earlier. And at this moment, I already have 2 identical angles in one triangle and 2 identical angles in the other triangle. So these triangles are definitely similar to each other. The third angle at the top is certainly the same here and here. These are the orange angles. This is triangle ABC. It would be useful to know how long this side is. This side is the entire length from here to here. From here to here, I have x plus 3. This entire side is the length x plus 3. And that's essentially everything I need to note on this diagram. Now I can set up proportion because I have to calculate the length of segment LB. Segment LB is this x. I'll calculate this x. I know the triangles are similar. The number 7, which is opposite the orange angle, matches the number 21, which is opposite the orange angle. And I also have 3, which is opposite the purple angle. And here I have x plus 3, which is opposite the purple angle. I can set up proportion, and we'll start with the 7 from the small triangle and divide this 7 by what matches from the large triangle, which is 21. That will be equal to. Now I'll take the 3 from the small triangle and divide it by this whole side x plus 3. I have proportion, so I can cross multiply, starting from the diagonal where there is x, but because there is addition here, I must enclose x plus 3 in parentheses, and the multiplication will look like this. I multiply 7 by the entire parentheses, so 7 times x plus 3. This equals on the other side 21 times 3. Now I will multiply the bracket. 7 times x is 7x, and there's also 7 times 3, which will be 21 with a plus sign, and on this side, 21 times 3 will be 63. To calculate x, this 21 is in my way. To get rid of this 21 here, I'll subtract 21 from one side and subtract 21 from the other side. On this side, I'll have only 7x left, and on that side, I'll get 42. So I have 7x equals 42. I divide everything here by 7. Here, the 7's cancel out. It turns out x will equal 42 divided by 7, that is 6. And that is segment LB. Task completed. In example D, I need to calculate the length of segment AB, this segment here. I know that BC is parallel to KL, BC is parallel to KL, and I have some given numbers here, the lengths of some segments. First, I make sure that I have similar triangles here. I will mark this angle here in orange. This angle will be a purple angle. It turns out that this purple angle, since these two lines are parallel, this angle is also in this place. These two angles are equal to each other, this one with that one, and similarly, this red angle that we have here at the top. Such an angle will also be in this place. Here we also have red angle. So if I now separate these two triangles, this smaller blue triangle, triangle ABC, I'll draw it here. This is triangle ABC. Here it has such an orange angle, here it has such a purple angle, and here it has such a red angle. I know there is x here, and I know there is 5 here. Now I'll take another triangle. This large triangle AKL is a green triangle. I'll take it here and draw it. And what about the angles? In this place, I have this angle. This orange angle is also in this place. This angle is this angle, this is the purple angle, the same as this angle here. So at this point, I know these triangles are similar because I have two angles like this in one triangle and two identical angles in the other triangle. But I will also draw in the third red angle at the top, which was here. So it turns out that here, we also have this red angle, based on these corresponding angles. I have red, purple, orange, red, purple, orange. The angles are the same in both triangles, so the triangles are definitely similar to each other. In this triangle, I also know a side with a length of 7. Now this side at the bottom, AK. If we mark side AB as x, because this is the side we need to calculate, then the side at the bottom, this side AK, will be x plus 2. So here I have x plus 2. I need to calculate this x, but since I know that the triangles are similar, I set up proportion. I start here with this 5. I'd take 5 and divide this 5 by the side that corresponds to this 5 from the other triangle, which is 7. And that equals. Now I'll take x from the smaller triangle, and the side that matches this x is the one at the bottom. It will be x plus 2. And I have this proportion. I can now cross multiply here. I'll start with this cross. It will be 7 times x, which is 7x. That will be equal to, in the other direction, I'll have 5. And what's here in the denominator, since there's addition, I put it in parentheses. I will multiply out the bracket. Here it will be 5 times x, which is 5x. 5 times 2 will be 10, positive 10. I will subtract 5x here. On this side of the equal sign, I also subtract 5x. From this, I get 2 x's. 5x's minus 5x's cancel each other out completely, leaving me with just 10. So I have that 2x equals 10. I will divide everything by 2. The 2's cancel out, leaving x, and here 10 divided by 2 equals 5. I calculated that x equals 5. Therefore, that side AB is equal to 5. That's what I had to calculate. This is where the task ends for me. In example E, I need to calculate the length of segment KC. This is the segment. I will denote it with x. This is my goal. In this picture, we can find two triangles. There is a smaller blue triangle, triangle AKL. I will draw it here on the side. In this triangle, I know side 13, and I also know side 5. I also have a right angle here in this place, and I will mark this angle here in red. In this place, I have a red angle. And I also have a second triangle, the green one, triangle ABC. I'll draw it here on the side as well. In this triangle, I have a right angle here. And in this place, I also have such a red angle, because in this place is the same angle as was here. I also have such an angle in this place. And at this moment, I already know that these triangles are similar because they both have this red angle and both have a right angle. So I already have two equal angles from both triangles. The triangles are similar, and therefore it turns out that this third angle, this purple one here, is the same as this purple angle in this green triangle. Now I will label the sides. Opposite the purple angle, I have the purple side AL. Opposite the red angle, I have the red side 5. And opposite the right angle, I have the green side 13. That is, in the smaller triangle. In the larger triangle, opposite the red angle is the red side BC. Opposite the purple angle is the purple side AC. And opposite the right angle, here I have the green side AB. In this larger triangle, I can actually only note the length of side AC. That is 13 plus x. And for now, I have a bit too little data, because I don't know this, and I don't know that. I only know a part of this segment, AB. Something else needs to be done here. Namely, we can notice that in this small blue triangle, since we have 13 and 5, I can use the Pythagorean theorem and calculate side AL. I will call it y, and I calculate this y using the Pythagorean theorem. I start with the hypotenuse, which will be 13 squared. This equals y squared plus 5 squared. 13 squared is 169. Y squared is y squared. 5 squared is 25. I subtract 25 from both sides of this equation. Here I subtract 25, and here I subtract 25. Here I will have y squared, and here 169 minus 25 is 144. Which means that y will be equal to the square root of 144. So this y will be 12. I have already calculated y. I know that here it is 12. So here it is 12. And since here it is 12, from here to here is 12, I can also calculate the entire side AB. This entire side AB is 12 plus 13, 25 in total. So here I have a side of 25, so I know at least one side of this large triangle. I can therefore act. I can set up proportion. First, I choose the color where I will have both sides known. That will be this green color, because here I have a green 25, and here I have a green 13. So I start the proportion from this. I take the green 13 from the small triangle, and divide this by the green 25 from the other triangle, and will complete the proportion like this. I want to calculate x, so I need to put it into proportion. And this 13 plus x will be on the bottom. And that was the purple side, so I need to put the purple side on the top, but from the smaller triangle. The purple side was this 12. 12 matches with the 13 plus x, with 12 on top because it's the smaller triangle. I have the proportion. I can cross multiply here then. I'll start from this diagonal. 13 multiplied. This is addition, so I need to put it in parentheses. It will be 13 plus x equals 25 times 12. 13 times 13 is 169. 13 times x is 13 x's. On this side, 25 times 12 gives me a result of 300. I don't want this 169 here, so I subtract 169 from this side and subtract 169 from that side. I will get that 13x will equal 131. That's how it looks at the moment. I'll divide everything by 13. Here I divide by 13, and here I divide by 13. This results in x being equal to 131/13, and it doesn't divide any further. This is the final result. I calculated the length of segment KC. And that's all for this video. Thank you for watching, and I invite you to tune in for the next episodes on the Planet of Mass channel.